have long fascinated Americans, and the railroads have been an integral part of the growth and expansion of our nation. So too in Collierville, ever since the Memphis and Charleston Railroad arrived in 1853. The railroad played an important part in the Civil War Battle of Collierville on October 11, 1863, when a train carrying Union General William Tecumseh Sherman arrived here on the spot of the original Collierville depot in the midst of a Confederate attack on the Union soldiers defending the town. I'm Mike Elliott, president of the Friends of the Morton Museum, and I'm here to talk about the largest attraction on Collierville's town square, Frisco 1351, a steam locomotive formerly owned by the St. Louis and San Francisco Railway. That turned out to be a very optimistic name. The railroad never ran west of Texas. It also never ran through Collierville, but it and 1351 did run through Memphis on the Birmingham to Kansas City route of the Frisco line. Built in 1912 as engine number 1313 by the American Locomotive Company in Schenectady, New York, it became 1351 when modernized in 1943. It mainly hauled freight trains, but during World War II hauled troop trains due to heavy demand. The Frisco line retired 1351 in 1952 and donated it to the city of Memphis. The city of Memphis exhibited it at the old Defense Depot and at the fairgrounds until it was moved to Collierville in 1992. And as you can see, the town has recently preserved 1351 for future generations to enjoy. The locomotive sits next to the Norfolk and Southern Main Line between Chattanooga and Memphis. That railroad, when part of the Memphis and Charleston, was the first railroad to unite the Atlantic Ocean and the Mississippi River in 1857. The Memphis and Charleston merged with the Southern Railway Company in 1894 and became part of the Norfolk and Southern in 1982. We are now standing in the cab of 1351. If you were an elementary school student in the 1920s and 1930s, climbing into a cab of a modern steam locomotive like this would be like a child climbing into the cockpit of an airplane or onto the bridge of the Starship Enterprise today. Filled with a myriad of gauges, valves, and levers, it had all the controls that the engineer and fireman needed to do their job. On the Frisco line, the engineer sits on the right of the train and the fireman sits on the left side of the cab. The engineer uses the throttle here and the reversing arm, or Johnson bar, to control the speed and direction of the train. These two levers here control the brakes, one for the train and a separate one for the engine. And the gauges, although we haven't reinstalled them because they're brass and valuable, provide a lot of information: steam temperature, steam pressure, brake air pressure, speed, and other essential elements of information. The fireman is in charge of maintaining a hot, even flame in the firebox. He does that by moving the coal from the tender into the firebox itself. He originally did that by hand with a shovel, but in a large modern locomotive like this, it's done with a mechanical stoker, a corkscrew-like device that functions similar to the ice maker dispenser in your refrigerator door. Let's move trackside and see how this all works now. Now that we've seen where the engineer and the fireman work, the rest of the train crew, the conductor or train manager, and the brakeman work at the caboose, usually found at the very end of the train. In addition to being the train office, it also contains bunks, a stove, and a restroom, so it serves as the crew break room. A steam engine works on a very simple concept. Start a fire, use the fire to boil water and make steam, use the steam to make the wheels go around, exhaust the steam along with the smoke and the cinders from the fire into the atmosphere. To do that with great efficiency and to generate enough power to make it worthwhile, you need a large, complex machine like the one next to me. So let's take a look at how that works. As we talked about in the cab, a mechanical stoker moves the coal from the tender into the firebox. At the same time, a steam-powered pump or an injector pumps high-pressure water from the tender into the boiler above me, 195 pounds per square inch in this case. From there, the hot gases produced by the burning coal pass through a series of tubes in the boiler, heating the water, boiling the water, creating steam. The hot steam, the wet, saturated steam, rises to the top of the boiler and collects in the steam dome on top of the locomotive. From the steam dome, it's sent to the superheater tubes, a separate set of tubes at the top of the boiler that superheats the steam from its boiling point of 380 degrees to 450 degrees, adding energy and creating more power. From the superheater tubes, the steam goes to the front of the locomotive, through a valve, into the piston and cylinder, and that's where the work is done, and that's how we turn the wheels. As we walk toward the front of the engine to look at that, let's take a look and talk about the wheels of the locomotive and their functions. At the back of the locomotive, the trailing truck carries the weight of the firebox and the boiler. When 1351 was modernized in 1943, the railroad expanded the size of both the firebox and the boiler and added this trailing truck to carry the additional weight. This truck is also kind of unique. It has its own small steam engine that generates about 800 horsepower to help start the train with a heavy load or to climb steep hills. As we move along, we come to large driving wheels or drivers. These carry the majority of the weight of the locomotive and provide the traction to move the train forward. On a car, the rubber may meet the road, but on a steam engine, the steel wheel meets a steel rail. So in order to get additional traction to start on a wet day, an icy day, or with a heavy load, the engineer can spray sand from the sand dome on top of the locomotive onto the track to create additional traction. So we'll now move to the front of the locomotive, look at the last set of wheels, and see how the valve, piston, and cylinder operate. And the final set of wheels for the locomotive are the front wheels, or the leading truck. And it does exactly what the name implies. It leads the locomotive along the track, around the curves, and through the track switches. And while we're at the front of the locomotive, look up and you can see the headlight, the bell, and the whistle. The whistle is that object that's at an angle in front of the smokestack. Now let's go back and talk about how the steam from the superheater tubes passes through the valve into the piston and cylinder and turns the wheels. As we talked about, the superheated steam comes from the superheater tubes down into the valve. The valve slides back and forth as the wheels turn, sending this superheated steam to either the front of the cylinder to push on the piston or send it to the back of the cylinder to push the piston forward. Unlike the piston in your car that only produces power in one direction on the downstroke, the piston and cylinder in a steam engine produce power in both directions. After the superheated steam passes through the piston and cylinder, does the work to move the wheels, it exhausts out the stack, creating a draft that pulls with it the hot gases from the burning coal and the smoke. It also creates the distinctive chug, chug, chug sound of a steam locomotive. To understand how the back and forth motion of the piston turns the driving wheels, we need to remember that old song that goes something like, the foot bone's connected to the leg bone's connected to the knee bone's connected to the thigh bone. In our song, the piston is connected to the piston rod is connected to the crosshead is connected to the main rod is connected to the side rod connects all the drivers together, turning them, moving the train forward. Now, to start the engine from a stop or to change direction, the engineer uses that reversing arm we talked about in the cab, and that's what this mechanism up here. The reversing arm adjusts all these linkages, the valve gear. Think of this as the transmission of the train. And to back up, it's a pretty simple operation. The engineer just routes the steam to the front of the piston, pushes the piston backwards, turning the wheels forward. To back up, he routes the steam to the rear of the cylinder, pushes the piston forward, and that turns the wheels backward. All that sounds pretty complicated, and it is. And another issue. This 500,000 pound piece of equipment beside me only produces 2,400 horsepower. It weighs as much as 100 SUVs but only produces the power of about 8 of them. For that reason, and as diesel locomotives became more reliable and more cost-effective, American railroads began the transition away from these large, complicated steam locomotives to diesel locomotives, especially out west where water was hard to find. World War II and the heavy use the locomotives underwent sped up the process of converting to diesel. So by the early 1950s, 90% of the locomotives on American railroads were diesel powered, and the last steam powered train, a revenue train, ran in the early 1960s. Thank you for joining us today, and if you have any questions, please ask the staff at the Morton Museum and we'll get you some answers.